Hello, it's Carl, and it's been now around about a year since I uploaded the last video on dataArtist. dataArtist, this is this program for scientific image processing, which mainly focuses at the moment on electroluminescence imaging of PV devices. The videos of the last year mainly focused on how to calibrate your camera, and the new set of images, which you will hopefully find now on YouTube, will focus more on practical problems. Practical problems, these include, for example, finding the best or the shortest exposure time, which fits given image quality criteria. Problems like focusing your image right, or correcting your images from these camera distortions, from perspective distortions, stitching multiple sub-images together, comparing images, and also how to extract the series resistance from a set of two images. In this video I would like to explain you how to determine the minimum or the best exposure time. Let's load a bunch of images. In this case, this is EL images of an EFG one cell minimule. And I guess you guys know this. We often have high bit camera sensors, in this case a 16-bit sensor, and we either have a low sensitivity or we have low exposure times, which causes to not use the full capacity of the sensor. In the result, our image often looks quite dark. What we can do, we can adapt the intensity range, which we see, for example with this slider, or now we just click right here, we click on fit, and then we just fit to an intensity range which excludes 1% of all existent intensities on the upper and the lower level. In this bunch of images we have different exposure times. We start at 6 seconds, then 18, and then a couple more where we added 6 more seconds. The question is, which of these images is already good enough? I'm speaking about noise. When is an image good enough? I mean, we could of course wait longer. The last image was taken, if I look here, at 60 seconds. Is 60 seconds already enough, or do we maybe need 2 minutes or 3 minutes in order to have a good image? Currently, the EL standard from the ISC says we should have a signal-to-noise ratio of 45 as absolute signal-to-noise ratio, so the signal should be 45 times higher than the noise level. So we could of course calculate this, but maybe we don't even care about the actual signal-to-noise ratio. We only want to know, is the current exposure time good enough, or do we have to set up another exposure time? For this, I created a tool called minimum exposure time. In this tool, you can set the image quality criterion. Let's leave it as it is. And you can set the exposure time. If you don't set the exposure time, you will only get a factor at the end, which applies to your exposure time. Or if you set the exposure time, it will calculate you the exposure time that you should apply on images in order to reach this image quality criterion. Let's click activate. And then the signal-to-noise ratio is calculated from just the current image. In the ISC standard, the current method of calculating the signal-to-noise ratio uses 2 EL images and 1 background image. This is an extended version which extracts noise from just one image and does a background exclusion method, which I won't describe here in this video. We just saw down there the resulting exposure time which we should apply. Thing is, this process bar only shows messages temporarily. In order to see what happened in the last time, what was printed in the last time, you can press either F4 or you can move this slider upwards. I like to press F4 normally, so here we go. This is the exposure time that you should have in order to calculate, or in order to obtain a good EL image which complies with the current quality criterions. Thank you for listening.